Algebra 2, this is Chapter 4, Section 4, and I'm looking at reflections now. This is going to be the fourth video in this series. There'll be one more after this one. So I'm going to keep my color blue because I'm going to do all of my x reflections in blue, my y in red, and my green for the x equals y line so that we don't get too confused. So I'm going to start with my square that I've been using, and I'm going to reflect this across the x-axis. In the x-axis, I've put a dotted blue line there to help us out here. So if I want to start with this point right here, and if I reflect it across the x-axis, I would end up exactly where I was. So I'm going to go to this point here, and if I flipped this one across the x-axis, I would flip it and it would end up just straight above it. And this one here would end up straight below it, right? So if it was 2 above it, it's now 2 below it. And this one was 3 above it here, and so now it's going to be 3 below it. And then we can draw back in our new square here that has been reflected across the x-axis. So let's look at a point here. So if this point were 5, 2, the new point is going to be 5, negative 2. So what happened here is if we had our point x and y and we're reflecting across our x-axis, the new point, well, the x stayed exactly the same and the y changed sides. It went from positive 2 to negative 2. Did that happen on all of these? Well, yeah, this one, the x's stayed the same and we were negative and now we're positive. We were at a negative 1, we're now at a positive 1. So we are just changing the sign on the y value. And so that's how we did this in Algebra 1. Let me go to my y-axis, and we'll take the same exact approach. So I have this point here, and if I go across the y-axis, it was 1 away, so it's going to be 1 away over here. And this one up here is 2 away, so it's going to be 2 away. And this one's 5 away, so it's going to be 5 away. And this one right here is 4 away, so it's going to be 4 away. And here is my reflection across my y-axis. So let's look at that same exact point. This was the point 5, 2, and now it is the point negative 5, 2. So now the y stayed the same, but the x's changed. So if I have my original point x, y, and this is again the Algebra 1 approach, so hopefully this is pretty clear for you all. So if I started at 5 and I went to negative 5, that means the x is changing signs and the y is staying the same. Okay, let's look at my last approach here, my green one. I'm going to go reflect across the y equals x line. Again, this is hopefully very clear that this is the y is equal to x line. Goes to the origin, so my y-intercept is 0, and my slope is actually a 1, so I'm going up 1 over 1, up 1 over 1, up 1 over 1. And if you think about logically, y equals x, so 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. Pretty clear y equals x. So let's start with this point right here. Okay, so it's the point 0, 1, and if I go straight across here, I'm going to be right there at, oh, sorry, this was 1, 0, this is now 0, 1. See, if I move this one across here, it is the point 2, 3. And it's now going to be the point 3, 2. So that one right there. That's going to be straight across that line here, see? So those points are going to interchange. And this point here is the point 4, negative 1. And it's now going to come across this line. And it's going to be the point negative 1 and 4 up here. And this one over here is 5, 2, and when it flips across there, it's going to become the point 2, 5. And did I do something? Nope, I'm fine. So here is my new green one. And that's my reflection across the y equals x line. So my point 5, 2, let's go to that one. It is now the point 2, 5. So what in fact happened is since it's y equals x, we're just flipping the x and the y. So the x, y would give or yield a y x point. Okay, so now that we've discovered what's going on in the Algebra 1 world, quick review from last year, hopefully, let's go into matrices and look and see how we can do this with matrices. Well, I don't really want to jump into my next slide yet, so let me clone the slide we're on here, clone this slide, and let me get rid of all of my writing here. So let's look at one of these at a time. So I'm going to go with blue again, and so my blue one, let's see, I just want to get rid of certain stuff. Hold on a second. Okay, I think I have them all set up now. So here we have our one that's going across the blue, which is the x-axis. So I'm going to stick with blue here. So if I'm going from 5, 2 to 5, -2, let's see, if this was our matrix, remember our x goes on top and our y goes on bottom, and we want to multiply it by something, by some matrix here, so that my x value stays the same and my y value is going to change signs. If I want my x value to stay the same, this means I'm going to have to multiply by a 1, right? I'm going to have to multiply by a 1. But what's the other thing going to have to be here if I don't want to have to add them together? Well, I'm going to have to add together because that's what matrix multiplication is, but the best thing to do would be to add 0. So if I multiply by a 0, that would be able to cancel out this 2. So that would make 5 times 1 and 2 times 0, which would give me 5 again. So that's good. And in the bottom, I want to not have anything to do with this 5, so I want the 5 to go away. So if I multiply the 5 by a 0, and then I just change the sign on my y, changing the sign on the y would be multiplying by a -1. So I would think if I multiplied by this matrix, this 1, 0, 0, -1, that would reflect me across the x-axis. So let's move down and let's look at the y-axis. So again, I've got a point here, and my point is 5, 2. And I want to multiply by some matrix so that I can end up with the x changing value and the y staying the same. If I want my x to change value, so I'm going to want something right here that's going to change 5 to a -5. Well, that would be a -1. And then I don't want to have a 2 there. I don't want to have to add my 2, so I'm going to multiply by a 0. So that would make this -5 plus 0, which would give me my -5. And then I want my y to stay exactly the same, right? So whenever I multiply my 5 times something, I want it to go away. So 5 times 0 makes it go away. And then if I multiply my 2 times a 1, I'm going to get my 2 again. So reflecting across the y-axis, I would multiply by this matrix -1, 0, 0, -1. Let me move down and look at my y equals x line. So this is my last one here. So again, my original point is 5, 2. And I want my new point to be 2, 5. So I want to change places here. So how can I get my 2 to be on top and my 5 to be on bottom? Well, on top, I want to cancel my 5 and keep my 2. And on the bottom, I want to keep my 5 and cancel the 2. So that would be a matrix right here with multiplication that would get me to flip those. So if I take the 5 times the 0, that would be 0. 2 times the 1 would be 2. That would, in fact, give me my 2 on top. And 5 times the 1 plus 2 times the 0 would give me my 5 on bottom. So you can see how that would flip my point here, and so instead of having 5, 2, it would be 2, 5. So let's put that all together on one screen for you. So here are my reflection matrices. So you can take a moment, pause the video, and write down the 3 reflection matrices. So you need to know that you're going to multiply by this 1, 0, 0, -1 for an x reflection. You're going to multiply by a -1, 0, 0, 1 for a y reflection. And you're going to multiply by a 0, 1, 1, 0 for your y equals x line reflection. And notice that they are always the first number to be multiplied. We always put them in the front. They never go behind. Remember, multiplication is not commutative with matrices, so it has to be the first number, or the first matrix. So pause And take all these notes down, please.